In this video, you are going to be asked to take algebraic terms that have exponents and multiply, divide, and take them to a power. Enjoy. So in this video, we're going to talk about operations with exponents. We've done a little bit of exploring with exponents, with solving equations with exponents, and with order of operations when we needed to do the E and PEMDAS. And now we're going to look at what happens when you have an algebraic term like 3x squared and you multiply, divide, or take it to a different power. But we first have to understand the different vocabulary words that are going to be used in the rules. The first is coefficient, which we've heard a million times in math, and that's the number that's multiplied by the variable. I don't know if we've ever spoken about a thing called the base, and the base is the number or variable that's repeated a number of times, and it is the only thing that's attached to the exponent. So the base is like a pirate, and the exponent is the parrot. It's on only the base's shoulder, and it tells you how many times, the exponent tells you how many times the base is repeated. So the third word is exponent, and we've spoken about exponent, and that just tells you how many times the base is repeated. So for 3x to the fourth power, it means that only the x is repeated 4 times. So 3x to the fourth means 3 times x times x times x times x. It is crucial that you understand this so that we can go forward. So when you multiply terms that have common bases, you are going to multiply the coefficients. You're going to keep the bases the same, and you're going to add the exponents. It's important to understand that you cannot apply these rules unless the bases are the same. So in the case of 4x to the 6 times 3x squared, you're going to multiply the coefficients, which are 4 and 3, and you're going to get 12. You're going to keep the base, which is x, the same, and you're going to add your exponents, so 6 plus 2 is 8. The reason this works is because 4x to the 6th is really 4 times x times x times x times x times x times x, or x 6 times. And 3x squared is 3 times x times x. Therefore, it's 4 times 3, which is 12, and x, 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 which are 8 x's, or x to the 8th. So whatever x is, you're going to take it to the 8th power because you're multiplying it by itself 8 times. So instead of listing it out the long way, you can apply the rule, which will give you the shortcut. With 5x times 2x squared, you're going to multiply the coefficients, which is 5 and 2, and get 10. You're going to keep the base the same, which is x, and you're going to add the exponents. Please remember that an x is the same thing as an x to the first, and that 1 should be on just the x. So if it's x to the 1 times x to the 7th, you would add 1 plus 7 and get 8. So it would be 5x and 2x, x, 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 x 7 times. So you would have 8 x's. So your final answer would be 10x to the 8th, which means no matter what x is, you're going to take it to the 8th power, and then you're going to go ahead and multiply that answer by 10. It gets a little trickier when you have 2 variables, but only slightly because the rules still apply. You're going to multiply the coefficients, so 3 times 6 is 18, and you're going to take one variable at a time. So you're going to do x to the 4th and x to the 8th. You keep the base the same, you add the exponents. You do y to squared times y, which is the same as y to the 1st. So y squared times y to the 1st is y to the 3rd, and that's your final answer. With division, you're going to divide the coefficients, you're going to keep the base the same, and now you're going to subtract the exponents. So you divide 8 divided by 2, you get 4. You keep the base the same, and now you subtract the exponents. And the reason why this works is because on the top, you have 5 x's, and on the bottom, you have 3 x's. No matter what x is, x divided by x will give you 1, and 1 times any number is that number. So I can cross out any pair of x's that are on the top and on the bottom. So that eliminates 3 x's on the top and the bottom. and leaves me with only 2 x's. So 8 divided by 2 gives me 4, and then that's where your x squared comes from because there's only 2 x's left. Again, once you understand that, you can just apply the rules. You divide your coefficients, you keep your base the same, and you subtract your exponents. Remember, if there is no visible exponent on a variable, you can put a 1 because 8 minus 1 gives me 7. And if I had 8 x's on the top and 1 x on the bottom, I would only be able to cancel out 1 pair, leaving me with 7 x's. In the case of the third example, you're not going to be able to get a whole number because 27 divided by 21 doesn't give me a whole number. So I'm going to go ahead and reduce that. And I can reduce it by 3. So I'm going to get 9/7. And then that's going to be x to the 5th because 15 minus 10 gives me 5. I could also divide 9 divided by 7 or 27 divided by 21 and get some decimal answer. But I would prefer you leaving it in fraction form. And then the last one, now you have 2 variables again. The rule still applies. You're going to divide the coefficients. You're going to keep the base the same. You're going to subtract the exponent. You're going to keep the second base the same, and you're going to subtract the exponents, remembering that the y that doesn't really have a visible exponent indeed has a 1 as an exponent. So when you take a power to a power, it means you are taking an algebraic term that's in parentheses and you are repeating it using multiplication the exponent number of times. So instead of just taking one number like 4 and taking it to the third power, you are taking an entire term like 4x squared and taking it to the third power, which means you are multiplying 4x squared by itself 3 times. The shortcut rule to this is taking the exponent and distributing it to both the coefficient and to the exponent on the variable or the base. So in this case, I would take the 3, which is the exponent, and I would distribute it to the 4, and then I would distribute it to the x squared. And x squared to the third power would be x to the 6th power. I multiply. Distribution, just like when we just use the distributive property, we multiply. So the 4 has an invisible 1 exponent. You multiplied the 3 on the outside by the 1, and you multiplied the 3 on the outside by the 2, and you got 4 to the 3rd, x to the 6th. You can simplify this to 64 x to the 6th because 4 to the 3rd is the same as 64, or you may leave it as 4 to the 3rd x to the 6th. The reason why this rule works is because if you were to use repeated multiplication and you were to list out the 4x squared times 4x squared times 4x squared, you could then use the multiplication rules that we learned 2 slides ago, which tells us that 4 times 4 times 4, which is multiplying the coefficients, would give me 64. I would keep the base the same, and I would add the exponents, which is 2 plus 2 plus 2, or 6. So I could, if I really wanted to take the time, to list out 4x squared to the third power as 4x squared times 4x squared times 4x squared, and then use the multiplication rules of operations with exponents, or I could just use the power to a power rule and distribute the exponent. So in the next example, I would take the 4 and I would distribute it to the invisible 1 on the 5. So it would be 5 to the 4th and x to the 24th. Again, if you would like to take 5 to the 4th power on your calculator, you can go right ahead. I'm going to choose not to. However, I believe if you do, you get 625. And then for the very last one, I would distribute the 3 to the exponent of 1 on the 2. I would distribute the 3 to the exponent of 5 on the x, and I would distribute the 3 to the exponent of 8 on the y, and I would get 2 to the 3rd, x to the 15th, and y to the 24th, or 8x to the 15th, y to the 24th.